The number 3.14, which has been given the name pi, is the ratio between the circumference of a circle to its diameter, and is the same for every circle. The word pi is the name of the Greek letter p. It's probable, I have read, that the name was assigned with the idea of periphery in mind. If one takes the measurement of the circumference of a circle, let's say it's got a string around it, you straighten it and measure it with a ruler. Then one measures the diameter of the circle and divides the circumference by the diameter. The answer will always be pi, or rounded off to 3.14. We learned that the number is rounded off because the quotient of the division problem, circumference divided by diameter, is an irrational number. Well, some people are irrational too, but that doesn't mean you can't put them on a scale and arrive at an exact weight. The relationship between the circumference and the diameter is one that is exact, but the number is elusive. If you want to calculate the area of a circle, you will employ the number 3.14 or pi in your equation. A equals pi times r squared. So the area equals pi 3.14 times the radius squared. Now, this is interesting. Ponder this. For any given circle, you can draw a square around it so that the circle fits tightly in the square. Now draw a cross through the square, making 4 smaller equal squares. The side of each small square will be the same measurement as the radius of the circle. Remember that the radius is half the diameter. In order to calculate the area of one of the small squares, one multiplies 2 sides of the small square. This corresponds to the r squared in the formula used to calculate the area of a circle. By squaring the radius, you are calculating the area of 1/4 of the original square drawn around your circle. So when you think about it, by multiplying this number, the area of the small square, by pi, 3.14, the area of the circle will be the same area as 3 small squares existing within the large square that you have drawn around your circle, plus about 14% of the 4th small square. To reiterate, just because you are using a number that cannot be described in an exact manner, that does not mean that when you put a rug in a circular space, you don't need a specific size or area of carpet to cover that floor. There's nothing approximate about it. Put it on a scale and you will have an exact weight. Of course, to be fair, the infinitesimal continuation of the number following the decimal point amounts to such a minute variance that it is as though irrationality doesn't exist. The point I am making is that the amount of carpet is concrete and fixed. There is nothing irrational about the space it occupies. Consider for a moment again the square drawn snugly around the circle. Take some scissors and cut the square out of the paper. Then cut the circle out of the square. The little remaining corners left will amount to about 86% of the area of one of the small squares when the large square has been divided into quarters. This is just another way of thinking about the same thing. If you grab another piece of paper, draw a square 20 centimeters by 20 centimeters, divide the square into 4 even squares 10 centimeters by 10 centimeters, cut them out, then cut one of the little squares in 2 pieces, 14 millimeters by 86 millimeters. Put aside the larger segment of the 4th square. Take this 3 small squares plus the small piece of the 4th square. Shred them into specks. Then spread them over a corresponding circle drawn on a separate piece of paper. It should fill the space perfectly. Thank you.